Hello and welcome to the Condensing/Expanding Logarithms video. In this video, we are going to practice using the rules that we learned from our last video, kind of back and forth or either direction with the rules. So either condensing things, making it smaller, or expanding things, making it larger. But before we do that, we do have one more, I guess you could call it rule, that I want us to go over. This is the change in base rule. Change in base. If you'll remember, we have a log, so if we have log base b of a, b right here, that is our base. Now, for logarithms, if we don't specify what b is, we say it's a base of 10. Now, most calculators can only deal with a base of 10, but what if this base is 7 or 9 or 2? What do? Well, we need to change the base to make it become a base of 10. And the way that we would do that is we would write this as log of a, or whatever was in our argument, divided by log of b, or whatever our previous base was. This now changes both of these bases to a base of 10. So now this is something we can use in our calculator. So again, this is something we use when the base is not 10. So for example, if you're looking at, there's no blank notes for this Go Formative, unfortunately, but if you take a look at the completed notes or at the eventual Go Formative, there's a change in base section. So if we take a look at problem number 6, we have log base 3 of 1.5. Now, some calculators can deal with this base of 3, some cannot. So since I don't want to penalize the people whose calculators cannot deal with this base of 3, I want everyone to show me the work of saying, hey, this is the same as log of 1.5, or whatever is in my argument, divided by log of 3, what my base was. Now these both are unspecified with their base, which means a base of 10. So when I plug this into my calculator, I'm going to get something super long and decimally. I'm going to round it to the third decimal place, but we get 0.369. And that's it. So let's try that once more. If we take a look at problem 9, we have log base 7 of 4.14. So again, some calculators can deal with this, some can't. So I want everyone to write for me log of 4.4 divided by log of 7. Then you can plug that into your calculator and you will get 0.761 as your answer. Now what I want you to notice here is that these logs, there's one log in the numerator and one log in the denominator. However, when you are subtracting two logs with the same base, you divide the inside. So there's still division, but there's only one log. To talk more about what I mean, let's look at the condensing section of this video. So if we look at condensing, on the Go Formative, there's kind of like a part 1 and part 2 of condense. So first, I just want to take a look at problem number 1 from that first section. So it just says log base 3 of 20 minus log base 3 of 4. So like I said, two logs of the same base being subtracted from each other, it's one of our rules, we divide our insides. And we end up with log base 3 of 20 divided by 4. So again, there is still division here, but the division's only in the argument. Whereas with our changing base formula back here, we're dividing the whole thing. So please, please, please be careful. But yeah, that's just using our rules. Inside this argument, 20 divided by 4, I can keep simplifying that into log base 3 of 5. So not too bad. But what if we had something that made us use a few more of our rules? Let's move this up. Let's take a look at problem number 3 from that condensing section of part 1. That says 3 log of 2 plus log of 4 minus log of, oops, pardon me, not 13, 16. So that one's a little bit longer. We're going to try to get this all into one log. So before we can deal with this adding or with this subtracting, we have to deal with any coefficients, or this 3 out in front. Now we have a rule that says if we take any coefficient, we can bring them to be an exponent in a logarithm. I know you may not remember all of our rules, so feel free to take a look at the Canvas page. It is available to you for 5-3, and you can observe the rules there. But when we bring this coefficient to be an exponent, this becomes log of 2 cubed plus log of 4 minus log, of 16. Let's see, 2 cubed is going to be 8. So this is log of 8 plus log of 4 minus log of 16. Now, I haven't been saying the base here because they don't specify the base. I'm going to assume it's a base of 10. I do not have to write that every time. Now, when I have something like this, in terms of our PEMDAS, or order of operations, addition and subtraction kind of happen simultaneously. So if I have addition and subtraction happening at the same time here, I always just read it from left to right. So since I come across this addition first, this is the first piece I'm going to be dealing with. So when we have 2 logs of the same base being added to each other, we multiply their insides. So this will become log of 8 times 4 minus log of 16, or log of 32 minus log of 16. And then from here, similar to problem number 1, we have 2 logs of the same base being subtracted from each other. This means we are going to divide their insides. So we'll have log of 32 divided by 16, or log of 2. So we can see here we were able to condense this whole thing down using, I think, 3 of our log rules to get to here. So this is condensing, taking something that's wide, bringing it smaller, or simplifying. To practice one more rule, in the second condensing section, I just want to go over problem number 2, then we'll move to expanding. So in condense part 2, problem number 2 reads, log base 2 of a divided by 3 plus log base 2 of b divided by 3 plus log base 2 of c divided by 3. Now, lucky for us, all of the denominators are the same, so we can just add all of these together, and we will get log base 2 of a plus log base 2 of b plus log base 2 of c, all divided by 3. Now remember, when we're adding 2 logs of the same base, we multiply their insides. And since both of these are adding, it means we're just multiplying everything. So this will become log base 2 of a times b times c divided by 3. Now I do want to keep going because this 3 here, this dividing by 3 is actually a coefficient, because we can rewrite this as 1/3 times log base 2 of a times b times c. So in order to properly condense this, I'm going to make this 1/3 be an exponent to everything inside the log. So I'm going to say this is log base 2 of bracket parenthesis a times b times c to the 1/3. So this is my way of showing that that 1/3 is not just going to the c, but to everything inside there. So be careful of that. So if you're dividing by something, it is still a coefficient. It's just a fractional coefficient. So that was the condensing piece of our video. We just are going to go over 3 expanding problems. and then we will be done. So for the expanding section, there's again 2 sections for expanding. Part 1 is really short, so we're just going to go over 3 questions from the part 2. From the Go Formative. So from part 2, first question we're going to go over is problem number 11, which reads as log of u to the 5th times v to the 5th. And that's it. So when we take a look at this, before I can deal with the exponents, I'm going to deal with this operation right here. So since we are multiplying 2 numbers inside of a log, we can separate them out by giving them each their own log and adding them together. So we'll have log of u to the 5th plus log of v to the 5th. And now that we've separated those out, the last thing I need to do is take the exponent and make it become a coefficient. So exactly the opposite of what we were doing in some of our other problems. And I'll do that for both of these logs. So that we end up with 5 times log of u plus, 5 times log of v. Now, for some reason, a lot of problems for logs like to use u and v, and I know that depending on your handwriting, a lot of these can look similar, so please just try to make sure your u's are curvy and your v's are angled. But there we are, we've expanded this into something larger. So let's try 2 more problems. Problem number 16 reads log base 5 bracket of u divided by v to the 4th, all of that to the power of 6. So remember, just because we're using logs doesn't mean we can forget all of our exponent rules. We have the 6 here being applied to all of this, so I'm going to use my power rule and bring this 6 to multiply to this exponent down here, as well as to the exponent of u. So u has an exponent of 1, so make sure to multiply that there. And this will become log base 5 of u to the power of 6 divided by v to the power of 24. So in order to separate these 2 numbers or 2 variables inside of a log being divided by each other, we can give them each their own log and subtract those. So we'll have log base 5 of u to the 6 minus log base 5 of v to the 24. And just like we did in our last problem, I'm going to take the exponents and make them become coefficients. So we have 6 log base 5 of u minus, there we go, minus 24 log base 5 of v. So this is our expanded answer. So again, we're just using the same rules but going backwards. Let's take a look at just one more problem. Problem number 19, which reads log, base 8, I'll redraw that, there we go, log base 8 of z cubed times the square root of x. So again, just like problem number 11, we have 2 variables or numbers being multiplied inside of a log, so I'm going to separate those each into their own log and add them. So log base 8 of z cubed plus log base 8 of the square root of x. Now, again, using our exponent rules, square root, that can actually be written as an exponent. We're going to write that as an exponent to the power of 1/2. So log base 8 of z cubed plus log base 8 of x to the 1/2. And then from here, take your exponents, make them become coefficients. So if you see a square root or a cube root, make sure to turn that into an exponent so we can bring it outside as a coefficient. And we get, 3 times log base 8 of z plus 1/2 log base 8 of x. And that is our expanded version. So rewatch this video if you need to. Let me know if you have any questions. I look forward to seeing you in class.